Okay. Oh, that's loud. Okay. So basically, we're just doing review tonight for the test. Okay. So anyway, this is the topics here for it. And so solve a constant coefficient homogeneous equation. This is also on the open math. I should have printed this part out, but so this one here, and then undetermined coefficients, and then variation of parameters, and then a spring problem. So, and for the spring problem here, right, constant coefficients, that's where you have like equal 0. The homogeneous, right, it's equal 0. And then on these two, you have like an f of x on the right side, you know, on non-homogeneous over here. So these are for these two things here. And then also a spring problem, something like that. And so, and for the spring problem, it'll be f of t equals 0 on the right side. So it won't be anything forced. It'll be either the damped or undamped but free. We did one on there where it was like we had some function over there and you had to do like a undetermined coefficients or something, but it'll be f of t equals 0. So it'll be equal 0 on the right side for the spring problem. So it makes it a little bit quicker. So, but okay. So let me kind of go ahead and get started here then. And I'll just kind of go through things. So one like this, perhaps. This is like section 5.2. I'll just kind of sketch them out here. I may not completely all finish them or whatever. But so something like this here, find the general solution. Okay, like y double prime minus 2y prime minus 15y equals 0. So this is like a constant coefficient, second order linear homogeneous equation. Okay. Basic idea here, right? You write down that when you're solving these here, you just write the characteristic equation. This is called the characteristic equation here. And you solve this. So however, what your favorite way of solving it is. I don't think I put the quadratic formula on there actually on the sheet. I think it's not on there. But if you need it, I don't know. I can write it in the board in here, or yeah, but quadratic formula, you want to know that if you don't have access to it. But, and I think probably everybody's, I don't know, if at this point can probably figure out what it is there. But anyway, so anyway, here on this then, actually this one you can use quadratic formula or just factors, right? So these factors, see r equal 5 or r equal -3. And then so immediately then, now you can look at the formula sheet, wherever it is. Well, okay, yeah, it's down here. That's this one right here, right? If you have, if they're real and distinct like this, then it's just like this for the general solution. Okay, so so that'd just be y equals c1 e to the 5. And I guess you could, I'll tell you where you use x or t. I'll say x here. Like that. So that'd be the general solution there for that one. So, and anything on that? And did I use, let me see here. Oh, I didn't specify here. On my formula sheet, I assume the independent variable is x here when I wrote this, but it could be a t for time. Yeah, so maybe I should fix that up sometime. But okay. But anything there? So that's that case. And then the second case, let me go down here, like this one. We'll find general solution. Okay, you write down the characteristic equation again. So it's like r squared minus 10r plus 25 equals 0. Okay, so you solve this one here. However you do that, you get r minus 5 equals 0. So you get r equal 5. It's repeated. This one's repeated. Okay, so in that case, it looks like this. Right, you say you have your c1 e to the 5x, and then for the repeated one here, c2, and then x e to the 5x over here. That's the general solution here. Okay, so anything on that? And again, that's on the formula sheet, something like that. If you look at it, where, yeah, like the second case, that's the second case here. So that's this one if it's repeated. Okay, so we got that. Let's see. Okay, third case here. Let's say find the general solution for this one. Actually, I have four cases here. Y double prime plus 25y equals 0. Okay, so characteristic equation here, r squared plus 25 equals 0. So here we get r squared. You could do your quadratic formula, whatever, go through it. You get r equals 5i, or r equals negative 5i, complex, or it's an imaginary number here. Right, now we solve that. Okay, and in this case, then, when you have these imaginary numbers here, it goes like this. Then it's y equals c1 cosine 5x plus c2 sine 5x, and that'd be the general solution here for that. That's like the third case on the handout there. Okay, and then finally, maybe one more look at here. Let's say y double prime plus 8 plus 8y prime plus 25y equals 0. Okay, and write down your characteristic equation here. So you're looking for general solution. So you r squared plus 8r plus 25 equals 0. Okay, this one's pretty much quadratic formula you have to do here. I see kind of buzz through the quadratic formula there. And you get r equals negative 8 plus or minus, that's square root of, I think I kept the numbers nice, square root of 64 minus 100 is, or 64 minus, is it negative 30? No, 64 minus 100. Well, 64. So 100 minus 64 is 36. Thank you. Okay, so negative 36 there. So square root of negative 36 over 2, like that. Okay, so you get r equals, so that's negative 8 plus or minus 6i over 2. So r equals negative 4 plus or minus 3i. So something like this. Okay, and then, so then, yeah, so this one here then looks like this. So you get y equals, it's e, we can do it different ways. C1 e to the negative 4x cosine 3x plus C2 e to the negative 4x sine 3x. Right, it looked like this here. Or you could factor out the e to the negative 4x there too. So this is okay here. Or if you factor it out, this e to the negative 4x, you can factor out. Because that would be the general solution there for that one. Okay, so anything on that one? Let's see. Okay, so that's that. Yeah, and I think that's how I wrote in the form, something similar. Can't remember. Yeah, so kind of, I put an example, I gave you an example there for that one. So, okay, so that's that. So that's for the homogeneous, constant coefficient homogeneous. So that should be pretty quick. You just do the characteristic equation and write it down the right way. So any questions on that? Okay, if nothing there, I'll move on to next thing. Next thing is, now we're gonna look at things like where you have something besides 0 over here now, right? So like some function of x over here. Okay, so let's say now use the method of undetermined coefficients. That's okay, I'll write it like that. To find the general solution, let's say. Maybe something like this. I'll do a few of these. So y double prime minus y prime minus 2y equals 8x plus 4. Okay, and right, the way this works, okay, the general solution to this here, okay, or to like a second order linear equation here, even if it's non-homogeneous, right, looks like this basically. At y equals y sub c plus y sub p. Okay, this is called a complementary solution. This is the general solution to the homogeneous equation. If this were 0 over here, right, that's this part here. That's called complementary solution. Okay, and then this is called a particular solution here. Okay, and I think I wrote it down on the sheet, kind of like that. So this is your general solution here. Okay, and so well, we got y equals, now the y sub c here, that's the general solution to this. Okay, and I think if you do that kind of on the side here, like r squared minus r minus 2 equals 0, you get like this here. So you r equal 2 or r equal negative 1. So for this part right here, right, that'd be c1 e to the 2x plus c2 e to the negative 1x. And that's the y sub c right here. Okay, plus y sub p. Okay, and then for the y sub p here then, okay, this is where you use the method of undetermined coefficients now. So basically, you look for this. And the form you pick here, it depends upon what this looks like over here. Okay, basically, it's either going to be like an e to the x sort of thing, or a sine cosine thing, or a polynomial, or some combination of that. Okay, and on the sheet here, I have some examples. There's some kind of examples here. I think back here. Yes, here's the undetermined coefficients method here. Okay. Yeah, like this here. And typically for this, these are going to be constants here. And when you do undetermined coefficients, these are usually constants here. They won't be functions of x. So it's more like I could put b and c here. Those would be constants for this. But yeah, but anyway, you look for this over here then. Look at this one here, right? And different forms here. So here in this case, we have like this, like a polynomial here. It's like the second one here, second example. So you want to pick something like this, right? You try this here then. Okay. So for our case then, go back down here, right? That polynomial. So we would try like, in this case, ax plus b. Because this is only first degree here. So you'd have your powers going down. So you try this here. So look for y equals ax plus b. Okay, now this guy right here then, this y sub p, that's actually going to be a solution to this up here. Because remember, this is like the general solution here to it. And if you choose C1 and C2 to be 0 here, right, that means that this is a solution to this one up here, because this is the general solution here. So if you choose C1, C2 be 0, right, then one possible solution is just this over here. And basically that's what we're going to do. We're going to assume this is a solution here and feed it back in up here. Okay, and then see if we can find the coefficients. Okay, so basically I plug this in. So I need two derivatives of this to start, right? So I take two derivatives, which would be 0, because this would go away. Okay, and then minus, now I take one derivative of this, and that'd just be a, right, minus 2, and then I have my function there, ax plus b. Okay, and this has to be equal to then, on the right side, 8x plus 4, like that. Okay, like this here. Anything there so far on that? So you get that here. And now basically at this point, you need to compare both sides here, the like powers. Okay, you could distribute it out if you want. You don't necessarily have to. like if you distribute this out here, you get like you'll get a term like this. You get x's and you get constants. You get these kinds of terms here, right? If you multiply it out, you get x's and you get constants here. Okay, so if I look at the x terms, okay, what would it be then? So imagine if I distribute it, what would be on the left side? I'd have negative 2a on the left. And what's on the right for the x? 8, right? So we got that here. Okay, and then for the b, or then for the constants, what I got going on there? I got a negative a, and then I'll have what else on the left side? If I were to multiply it out, a negative 2b, and then on the right side for constant, we have the 4. Right, so you get this here. Okay, and then to solve these for a and b, right? So here then you get that, I guess that'd be a equal negative 4 from this one. And then we got what? Negative 4. So negative 4 minus 2b equals 4. Okay, so I guess you get there that what? Negative 2b is equal to 0. Right, so it looks like b is equal to 0 there on this one. Okay, so then that would just be then, well, we get the a was negative 4, right? So the y sub p here would be negative 4x for this. Okay. Okay, so then, so the general solution then, right? So I can say then, so I got the yp is equal to basically going to be 4x here, because the a's, I'm sorry, negative 4x, right? The a was negative 4 and the b was 0, if I did that right. Okay, so then the general solution would be up here then, just put that in for the y sub p. So y equals c sub 1 e to the 2x plus c sub 2 e to the negative 1x minus 4x. Like that. That'd be the general solution then for the whole thing. So if you kind of start with this here and then kind of start filling in pieces, you know, kind of break it down there then. All right, so anything? Now they're going, it's kind of hard to set up in a way, but I don't know, because there's different cases and stuff that makes it kind of crazy. But let's try this one here. Let's say we got y double prime, same thing. Okay. Let's say, oh, by the way here, notice in this, I really didn't need to find, to get the y sub p here, if I ask you to find a particular solution only, you really don't have to find this in order to do that, but actually you should, because you could get duplication. So I guess it's just good to find this anyway. Always find a homogeneous solution first, that part, and then we'll see on this one. Let's say find a general solution here. So y double prime minus 4y prime plus 3y equals 2e to the 3t, like this. Okay, so first thing, I kind of structured out here. I say got y equals y sub c plus y sub p. Okay, that's going to be the general solution. Looks like this. For the y sub c there, you got to solve the characteristic equation. Right, like this. So you get r minus 3, r minus 1. Say r equal 3 or r equal 1. Okay, and then so what? We got y equals that c sub 1 e to the 3x plus c sub 2 e to the 1x, I guess, plus y sub p. Okay, so now for y sub p, we're using method of undetermined coefficients here again for this one. Let me check here real quick, make sure I got these going here. Okay, so right, method of undetermined coefficients. So then now for the y sub p, okay, so what? Basically, we got if you look at the forms there, it'd be like, it would be this, right? It'd be like a e to the 3x. Or I mean, I get t's and x's here. Wait a minute. I gotta be consistent. I'll use t's for this one, I guess. Okay, I'll use t's here. But anyway, but you notice in this one, we got e to the 3t, but the problem is here, okay, this isn't going to work because there's no way this can be a solution here to this, right? Because, let's see. Yeah, because this is actually a solution to the homogeneous one here. So, a e to the 3t. So, basically here, this is where you have the duplication with this over here. Okay, so you notice it duplicates. So if you find this e to the you see e to the 3t here, but it also appears as this one over here in the homogeneous solution part. Okay, so yeah, so what you got to do here, this is where you got to put it. When you have duplication, you got to put like a t in front of here. Leave a little space here. You got to go for this instead. So try this here, right? So you look for this. And this is where we talk about duplication on the sheet here. Okay, so I think it mentioned it back here. Did I say that somewhere? Yeah, see right here, right? If duplication, oh yeah, and I have it here for this one too, right? If duplication, try this instead. So that's what I mean by the duplication. If it's duplicated with the homogeneous part over there. Okay. So anything else so far? Okay. All right. So look for this instead. So now you do the same thing here. Okay, so you got to go through a little bit messier on this one now. So you got to go through and take two derivatives here of the first one. Now, one thing that might help here a little bit, I think I wrote this on there too. For taking two derivatives, you got to use like a product rule here, right, to take the derivative. Okay, when you sub it back in up there. This one here can help. Okay, this is like a product. It's on the formula sheet there, but it's like product rule for second derivative. Okay, so it can save a little bit of work when you're taking a second derivative here of a product like that. Okay, so if you plug that back in up here, then so I got to take two derivatives of this. Right? I need two derivatives of this to start. So now I'm subbing here. So subbing into the DifyQ, I got to take two derivatives. So I can use basically if I use this here. So what that says is, or they got it backwards. Wait a minute. I'm sorry, I messed this up. I think I'm going to do it the other way. I got that backwards. U double prime V plus 2 U prime V prime plus U V double prime. Is that the way I wrote it? Yeah, in the paper. Okay, that's what it should be. Look like that instead. Okay, but anyway, subbing here then, so I had it written wrong. So you got to take two derivatives of this. Well, if I take two derivatives, say it's like the first part and this is the second part, like the U and the V. If I take two derivatives, this goes away. Right, so that goes away. So I'm done with that one. Now I get what then? Now that takes care of that part. Okay, now for the next step then I need 2 times U prime V prime. So that'd be 2, take one derivative here and one derivative of this. So that'd be like 3 e to the 3t, right? Plus, and now for the last part of it then, I keep this one and take two derivatives of this. Right, so I keep this one now. So it's AT, and then two derivatives of this. That'd be 9 e to the 3t. Like that. So that's doing two derivatives there. Anything on that? Okay. If you don't like that particularly there, what you could do, you could just take a derivative and then take another derivative after that, and then clean it up, and then that's your y double prime. But that's not too bad there, I don't think. And then minus 4 times, I'm subbing in here. So y prime then, that's just now a single derivative here of this. Okay, so use the product rule there again. Okay, so for that, then you take the derivative of the first part. And did I put the product rule in here? Maybe I didn't. I put the two derivatives one, but so the product rule, then take derivative of the first part, right, which would be A. You keep the second part just like it is. Now this time you keep the first part and multiply by the derivative of the second part. Right, like that. Okay, and then plus, down here somewhere, I guess I'll write it, plus, and then 3y, so that's 3 times, and then the y is there, at e to the 3t. Actually, you need parentheses in there, really. Okay, and that's going to be equal then to 2e to the 3t, like that. Okay, so anything there so far in that? Okay, and I'm looking at my sheet here real quick. I don't know if I put the product rule. I don't think I put the first one on there. Did I even put the product rule all? Oh, differentiation rules. Yeah, it's there. Okay, so there's the product rule up there, the regular one, and then I added this one on down here then. So, okay. I use these sheets for different courses, these derivative rules, and I tacked this. This was tacked on later. Not very consistent looking, but okay. So anyway, okay, so now we got that here, right? So we subbed in. Now we just need to compare coefficients. So different kinds of terms here, right? There's going to be, you're going to have e to the 3t type terms. There's also going to be t e to the 3t type terms. And I think those are the only two types we have, right? Those would be the different, like here's a t e to the 3t type term, right? So those are the two kinds we have there, looks like. Okay, floating around in this. Okay, so now we just need to try to compare coefficients. Okay, and hopefully this all works. So look at e to the 3t's. What do I got going on here? There's, this is 6a here, right? So it'd be a 6a. E to the 3t, not that. This would be one here. And that's going to be like a negative 4a when you distribute it. You don't actually have to distribute it, right? But that'd be a negative 4a there. Okay, and then not here. And then we got this one over here. So that's got to be equal to what then here? 2. And that's the 2 in front there. So we got this. Okay. And then hopefully this works out right because I don't have very many letters here. So now if I do t, now I look at the t e to the t's, I got what? That gives me I got a 9a there. I say a 9a and right, minus 12, right, minus 12a from, right, we distribute that negative 4 through, right? So negative 12a there. Okay, and then here I got plus 3a, thank goodness, right? Plus 3a there equals 0. And on this side, it's what? It's 0 over here, right? Equals 0. Okay, so then, yeah, and this one just goes away here, the second one, because it's basically 0 equals 0, right? So there's no restriction. A can be whatever to satisfy this one. But this one here then, well, you get 2a equals 2, so a is equal to 1. Okay, so a is 1 here. So that would be the a then. Okay, so you can piece it back together then. But we got the a. So the a is 1, right? So the a is 1 there, and they can write the general solution back down. Because we know the a is 1 there now. Right, so we got y equals, that would be c1 e to the 3t plus c2 t e to the 3t plus, and then that was, plus, wait a minute. Oh, it says t, is it? I'm sorry, it didn't repeat. It was, forget that. This is c e to the, was it negative? I don't remember now. 1t, okay, or 1t. Okay, and then that is, and then plus, and then we had 1, that's the a, and then t e to the 3t, like that. So that would be the general solution then. Okay, so anything on that one? Okay, one more to go with those. So we'll use method of undetermined coefficients again. Let's say y double prime minus 25 y equals sine of 2t. Okay, basically same process here. So let's say I want to find the general solution. So that'd be y sub c. Now the y sub c here, I think that's going to be, it's going to be like a 5, or I'm sorry, well, I'll just write it out here. So write y sub c plus y sub p. And you do your characteristic equation thing there. That's going to be what, c1, I think it'd be cosine 5x plus c2 sine 5x. That's for the y sub c. Yeah, right. And then plus y sub p. And for this one, then look for what? So look for y sub p equals, and then there's a form on there for that. I kind of gave an example for that one. And yeah, so it's going to be like this. If you have a sine or a cosine there, you got to go like this here then. Okay, and so back down here, wherever it was. Right, so look for a, I can't remember first, sine x or cosine x. I think probably cosine. It doesn't matter. Plus b. Did I? Okay, whichever order you want, it doesn't matter. Let's see. I'll just write it this way for now, I guess. But should I do it like the sheet? Maybe I should do it like the sheet. I don't know. Which way are you guys doing it? Like the sine or cosine or whatever, whichever, it doesn't matter. Okay, so look for something like this here. Okay. Is that where I wrote in the sheet? I wrote sine and cosine. I should have written it the other way, but it doesn't really matter. Yeah, I did. Okay, but anyway, it doesn't matter. So, so look for this here. So now we go back up here. Take two derivatives, right? What's that? Oh, I'm sorry. I'm sorry about that. It should be like this. You're right. You're right. Yeah, it should be like that here. Okay. Good. Okay. Now we're going to do this, but if that were a sign, if that were, and I'm mixing my T's and X's. I'm sorry about that too. Oh boy. Wait a minute. You want X or T? I don't care. Which way do you guys want to go with this? Do you want X's or T's? Okay. Okay. There. Okay. So yeah, we get this here then. Okay. Now, if that were a sine 5t up there, okay, if it were like that, it'd be duplicated here then. And then what you have to do, you'd have, don't do this, but you'd have to put like a times t. We're not doing that. It's not in this one. Okay, but that's what you'd have to do though. I put the example on there anyway. But okay, so anyway, same thing here. You got to take two derivatives there, right? So take two derivatives there. You'll get back to sine again, but you'll get like a 4, because every time you kick out a 2. So I think, and it'll change the sign on it. So you got like negative 4a sine 2t. This is, so we're subbing now into here. And it'll end up a minus here, minus 4b cosine 2t. That's taking two derivatives there. And then minus 25. And then we got a sine 2t plus b cosine 2t. Okay, equals sine 2t. So this will be your setup here then for that. Okay, so anything there? So I just took two derivatives. I'm basically plugging in here, right? Took two derivatives there. Kind of carefully tried to, and then sub the other one and get this then. Okay. Now again, then you want to compare coefficients here. So what kinds of things have we got? We got basically sine 2t terms and cosine 2t terms. Okay, and we'll kind of scan across here. So it looks like on the left I'd have negative 4a, and any more? Yeah, that's a minus 25a. And then on the right, what would that be? Well, I 1. You're way ahead of me. That's all. So minus 1. Then down here we got negative 4b and that'd be plus 20 or minus 25, minus 25b equals 0. 0 there, right? So we get the b pretty quickly. The b is going to be 0, right? Because we get negative 29b equals 0. So that's got to be b equals 0 there. And then for this one, then, okay, then you just solve that for a. So you get negative 29a equals 1. So a equals negative 1 over 29, or negative 1/29, like that. Okay. So we got the pieces here, right? The a is negative 1/29. The b is 0. Okay, and then and then you got that up here. Okay, so now on the test, I might ask you to find a y sub p, like not necessarily the general, but if it's asked for y sub p, that'd just be this part here. Okay, if asked for y sub the particular solution, okay, the y sub p, that would just be this part here. But anyway, the general solution would be then what? It'd be C1 cosine 5t plus C2 sine 5t. Then minus and then particular solution was this, and the a was negative 1/29, so minus 1/29 sine 2t, like that. So that'd be the general solution there. And so, anything on that one? Okay, so that's undetermined coefficients. Okay, next up is variation of parameters. Okay, so let's say here use variation of parameters to find the general solution. Okay, this is like section 5.5 if you're keeping track of that. But anyway, here then, so y double prime plus 10y prime plus 25y equals 7e to the negative 5t. This is an example here. Okay, so we got this. Do we use x's here instead of t? We'll do x maybe. It doesn't really matter, but x, I think x is a little easier. More used to x's. So anyway, so same starts off the same, right? So you got y equals y sub c plus y sub p, and then y equals, and then this is the complementary solution. Okay, that's where you have 0 over here. You go through a characteristic equation. It's going to be, you get like r plus 5, r plus 5. So it's like the r would be negative 5 then. So I think I'm get this right. Right, I think that's right. That would be your complementary part here, right, for the homogeneous part. And plus y sub p. Okay, anything there so far? And this came from, right, that's doing r squared plus 10r plus 25 equals 0, right? R plus 5 equals 0. So r is negative 5, and that's this here. And it's repeated, right? So you got the extra x in there for the homogeneous part. So that's the homogeneous solution there. That's the y sub c, okay, plus y sub p. Okay, now we're using variation of parameters, and a lot of things in this one. So kind of start at the bottom. Yeah. What, this one?
Yes.
Okay.
No, I'm talking about the multiplication board. Why we put the x next to the C2?
Oh. Okay. I see. Yeah, because it was duplicated in the. You see, for the characteristic part, this here. Okay, you put 0 over here, right? To find that. Okay, for this thing here. So you get this right here, right? R squared plus 10r plus 25. So when you go to factor it, it's r plus 5, r plus 5. So you get r equal negative 5. It's repeated, right? And that's the case then if, right? Yeah. So that's one of the cases up there where it's, if I just go back real quick, it's back up to this guy here, right? Okay. So Whoops. Okay. Okay. Now, by the way, I'll just say real quick, if you're doing undetermined coefficients here with this one, if you did the other method, okay, then it's actually, if this appears in here, but also if I put the x in front, it also appears here. So if you're doing undetermined coefficients, that'd be x squared. When you do your y sub p, you have to put an x squared there if you did undetermined coefficients. Because if you did x e to negative 5x, it's still not enough because it appears here. So you have to go x squared next. But you don't have to worry about that here for this. Okay. But anyway, then, now the y sub p, okay, this is where variation of parameters comes in. There's a thing called w. It starts with w here. Okay. So kind of working our way back up on that. So it's this determinant here like this. And you put the homogeneous solutions here, like, so in the e to negative 5x, x e to negative 5x, like this. Okay. And actually, let me go down one line here. I'll show you one thing, right? For the y sub p here, right? It looks like this. You have like a u sub 1 e to negative 5x plus u sub 2 x e to negative 5x, right? It's going to have this form here. For the y sub p, it's going to look like this. Okay, where these are like functions of x here that we got to find. Now, in order to find these u's, okay, now you first got to find this thing here, okay, where you use these parts here, right? Those go here. Okay. Now you take a derivative here. So that's negative 5 e to negative 5x. Take derivative here. I guess I need a little more room. Derivative of this one, I use product rule. So that'd be what? Derivative of x is 1. So you get e to negative 5x. Now you keep that one. It'd be like, you go through it, it'd be like minus 5x e to the negative 5x, I think. That's taking a derivative using the product rule there, right, to take the derivative. So that's called that's W. It's called the Wronskian there. But anyway, then, so now you do your crisscross thing here for the determinant. Okay. So, and then that'd be what? E to negative 10x, because you add your exponents, and then minus 5x e to the negative, this should be minus 5x up here. So now I'm multiplying these. So it's e to the negative 10x minus 5x e to the negative 10x. Okay, and then minus, now you do this one here. I guess that turns plus then. So you get plus, and then you get 5x e to the negative 10x. Because when you multiply, remember, you add the exponents there. Okay, so any that so far? So that's just doing that determinant. You multiply, crisscross, multiply, and subtract there. Okay, and then these go away then, right? So these two cancel nicely for this. So you get e to the negative 10x. Okay, now then u sub 1 prime is equal to, now as a formula for that then, it's negative y1. Is that right? I got the, or is it, wait a minute, is it, remember how that goes? It's negative y2. I'm sorry, negative y2, is it? Negative y sub 2 times f of x. And that's, now the f of x comes into play. What was our f of x? That was this one up here, right? So that's finally where we start using the f of x now. So it's 7 e to the negative 5x over, and it's divided by the w, the e to the negative 10x. Is that right? It's negative y2. Now it goes negative y2 f of x. Is that the formula? Can't recollect. I think that's, okay, it's negative y2. Okay, right, so we have that. Okay, and then if you clean that up, now you notice what happens here. So you get what? u1 prime is equal to, nice cancellations happen here, right? And you get negative 7x. So that's u1 prime, it's negative 7x. Okay, and then I guess you can finish this one off then here. So u1 is equal to, now antiderivative there. So it's negative 7 times 1/2 x squared. No plus c needed here on this. So u sub 1 is equal to negative 7/2 x squared. Okay, and u sub 2 prime Okay, that's negative y. Is it negative y1? Are they both negative? Who knows? I gotta check. It's not negative? Okay. The y1's not negative? Okay. So, okay. So it's y1, which is, that's the e to the negative 5x. Yeah, e to the negative 5x. And then now the f of x, again, same thing. Okay, and then again, divided by the w, e to the negative 10x. So u2 prime, and again, it's nice in this one. They don't have to be nice necessarily. You know, the method gets messier if they're not nice. Okay, but basically then you get 7, right? That'd just be 7 there. Okay, so then u2 is equal to 7x, like that. So then we get y sub p then. It's negative 7 halves x squared times e to the negative 5x plus 7x, that's u sub 2, times x e to the negative 5x, right? That's the u sub 2, or that one. Because you get this here then, like that. Okay, and in this case, it actually simplifies somewhat here. Yeah, so that's the particular solution there. And if I write the whole thing now, I get y equals, we basically got the work done, but C1 e to the negative 5x plus C2 x e to the negative 5x plus, and then the particular solution here. So negative 7 halves, or I can say minus 7 halves, x squared e to the negative 5x plus 7 x squared e to the negative 5x, like this. Okay, and actually then you can put these together if you wanted to, right? Because these could go together here. And so you get y equals c1 e to the negative 5x plus c sub 2 x e to the negative 5x, and then plus, that'd be positive 7 halves x squared e to the negative 5x. It's like this here. That'd be the general solution then. Okay, so anything on that one? Because that's the variation of parameters there. Let's see. Okay, so that's that one. What do you think? Do you guys, should I set up one more? Or, but any question on variation of parameters, how that goes? Yeah, it's pretty much just plugging things in, right? As long as you can you just plug things in, and then it gets a little bit messy. There might be one, I'll just kind of start it very quickly. I may not go through it, but it could get a little messier, you know, like this, for example. Okay, like, so variation of parameters, you could have other functions over there and stuff, right? So, like, for example, here then, it starts off the same way, right? You got y equals y sub c plus y sub p, and then y equals, your y sub c here, that's going to be like 3, it's cosine and sine. So, I'm sorry, so c1 cosine 3x plus c2 sine 3x. I might just start this one, get it started. Okay, like this here. Okay, that'd be the complementary solution here, right, for that, plus particular solution. Okay, and then the yp looks like this then. It's u sub 1 of cosine 3x plus u sub 2 sine 3x. Okay, so look for this would be for the variation of parameters then here. And then you go through the same process, right? So, so you get your w here. You get like, let's say I have cosine 3x and sine 3x. Take derivative, or and 3 cosine 3x. think I did it right. Okay. So then you do the thing here with this, and you get like what would be 3 cosine square 3x, and then it'll turn into plus here, plus because he's tracked the other direction. Yeah, plus, and then 3 sine square 3x, like this. And then this is going to be 3, because you can factor out the 3. Sine square cosine square equal 1. So that's 3 there, right? So then you do your same thing here. You get u1 prime is equal to, it's negative this one, right? So negative sine 3x. Now this is where it gets messy. Now you bring in your function here, tangent 3x up there. This is divided by 3 here, though. I guess it's because that was 3. And then u2 prime, I'll write that down. So that'd be cosine 3x times f of x. And that is, again, tangent 3x over 3, like that. Okay, so anything there so far on that? Let's see, does that look right? It's negative y2 and tangent. Oh, okay. Yeah, I wasn't liking the looks of this here. But anyway, so like this one here, then, well, let me go over this one first, right? So u2 prime, that would be tangent is sine over cosine, right? So that would just be then the cosines would cancel. So I think you get like 1/3 sine 3x for that one. Okay, then it's your antiderivative there. Okay, that one's not too bad. And then this one over here, what is going on here? That would be maybe you're right. I'm sorry, where the u sub 2. Oh, I didn't take the derivative. I didn't do that. I just simplified this. Because this is sine over cosine, right? Sine over cosine. And then I didn't finish it. Yeah, u2 is equal to, and that'd be negative 1/9 cosine 3x. Is that right? Because the antiderivative of sine, yes, that'd be that one over there. Okay, and now this one over here, what is this about? That would be, so you got negative sine 3x times tangent. That is sine over cosine. Oh, well, wait a minute. See, sine tangent. I had some special ones on. I had some different ones on there on the sheet. I'm trying to think if that would work with any of them. So sine 3x. That's messier than I thought there. So that is sine tangent. So which ones I give on there? I gave a couple on there on the sheet. Let's see. I gave some of these guys here. Okay. So we had those 4. I don't think it looks like any of those actually. Let's see. Let me go back here and look real quick. I thought we did one somewhere in class with a tangent there. Maybe it was a cotangent I did. Let's see. And that one's a bit messier. I want to just check real quick here. The previous one we did. They did something similar. I'll get through this very quickly. Did I do cotangent? Yeah, I did cotangent. That makes a difference, I guess, in this. Let's see. Fine. Okay. Let's see. Yeah, I can do a little bit. Okay. Yeah, so, okay, this one here. But that's tangent. Wait a minute. It's going to be sine square. This one's going to turn messier, I think. There's no way to get around unless I made a mistake somewhere. I don't want to belabor it too much, but what was it? Cosine. That was cosine and sine. That was my U1, U2. Took derivatives. Derivative there, derivative there. This is my y sub 2 then. Then my f of x was tangent 3x. It might just be messy. And then that's that one over 3. Okay, and then this one over here, that was y1 and tangent 3x over 3. That one simplified nicely. This one I am... Let me see there. That is... negative sine square 3x over cosine 3x. Now, sine square I could write as 1 minus cosine square. Let me see here. I'm not going to give up quite yet on it. Yeah, okay, so that would be like that. Okay, so then I can do y1 prime equals, I distribute that now. It's getting messier than I thought. Negative 1 plus cosine square 3x over cosine 3x. Okay, and then you could break it. Okay. So this becomes like negative secant 3x plus cosine 3x. This is a messy one. So you can get it eventually like this here. Okay, and then this one you can do antiderivative here then. So, okay, it's a bit of a mess. I might have fumbled up here a bit, but this here you could write like, if you do sine square is 1 minus cosine square, like this. Okay, and then you distribute that out, and then you could get it like this, and then you break it. This is negative secant, and this is cosine 3x here. And then this is on the sheet here, right? That's on the sheet for antiderivative, and this one, you know, get this one here then. So that'd be the U1 then. This one's a little messier one, but any questions on it? I'm going to move on. Let's see. Okay. Let's see. Yeah, 6.1.6.2. This is the springs. Okay. One like this here. Oh boy, my time. All right. So I'll just get started here. So I'll probably do the harder one here. Write this down. So let's say an object stretches a spring, say 20 centimeters. The mass is pushed upwards 8 centimeters, and given a downward velocity of 2 centimeters per second, and then find y of t. Okay, so I'll find this here then. So now on the sheet, on the formula sheet, I gave you a few things there. You got m double prime plus cy prime plus ky. In this case, it's going to be equal 0. Okay, because there's no forced motion on it. Okay, so this is the mass of the thing. What the object is. This is the damping constant here, and then this is the spring constant here. Okay. On this one here, we're assuming c is equal to 0. Okay, so we'll assume c is, there's no doesn't mention anything about that. So c is 0. Okay, and then you could write like this then. If you divide through by m, then you can get it like this. Okay, so y double prime plus k over m y equals 0. Okay, and then there's a thing on the formula sheet. It'll mention, I think, about the displacement of it. Okay. Oh, and also have to give you the acceleration of gravity here. Let's say use g equals 980 centimeters per second squared. I gotta give you that too, acceleration of gravity. Okay, so basically this guy right here, the K over M, okay, K over M is equal to G over X, where X is the displacement stretched here. Okay, I have the spring was just resting. So the K over M here is G over X. Okay, that's gonna be 980 over, is displaced 20 here. So that gives you the K over M. So K over M here is equal to 49 in this case. Okay, anything on that? Okay, because when it's in equilibrium, yeah, when spring's equilibrium, right, it has the weight acting down on it, and then the spring then there's like this acting up, Kx is acting up on it. So when it's equilibrium, these two things are equal to each other. Okay, so and then you can you get this ratio here then, like this. So then the K over M is equal to 49. So you don't need the mass. You don't need the mass. You don't need the spring constant. You just need the ratio of them. Okay, so then you got what? Y double prime plus 49y is equal to 0. Okay, and then initial conditions here on this. What's y of 0? So y of 0 would be equal to what? 8. Yeah, because it's pushed upwards 8 centimeters. Okay, and then y prime of 0 is what? In this case, it's given a downward velocity of 2 centimeters per second. Okay, so -2. Okay, so we got that here. So then you just got to solve this initial value problem. I think once you get to this point, it's rather easy. It's easier once you get through the words, get through all the setup. But anything else so far in that? So now this is a homogeneous constant coefficient. Right, so get y equals, that's going to be C1, I think it'd be cosine 7x plus C2 sine 7x. Okay. Yeah, so this is it here. It's just a homogeneous equation. So we got that. So, my bad. Sorry about that. I need t's here. Say t's for time. Okay. The x here, I'm just using the x right there. That's just for the displacement initially. Okay, for that downward 20 centimeter stretch there. But anyway, you got this here. Now you got to find the C1 and C2, right? So remember, we got these conditions here, right? We got the conditions. We got a condition on y, also a condition on derivative. So I want to take a derivative here then. Y prime is equal to, that'd be -7c1 sine 7t plus 7c2 cosine 7t. And then just plug in the conditions here. Okay, so I know y of 0 is equal to 8. So if I put 8 there and put 0 over here, I just get 8 is going to be equal to C1 because this will drop over here. And then from the second one, y of 0 is equal to -2. So if I put -2 there and 0 over here, now this drops, and that's a 7c2, things like that. Okay, applying the conditions there. And then you got them here then, right? So C1 is 8 and C2 is -2/7. Right, so that gives you these guys here then. And then you got the answer. So okay. So right, so y equals the 8 cosine 7t minus 2/7 sine 7t, like that. Okay, anything on that one? Okay, and then on the other one, I'll just write it down real quick. For the other case would be like if there's a damping constant, I would give you something like this. I would tell you the mass. This might be other type. Then I'll tell you the mass. I'll tell you the spring constant. I would tell you the dampening constant. I would tell you the conditions. It might be in words, all this stuff a little bit, but I give you all these things here and then say find y of t. Okay, and this one is just a setup. You just set it up here then. And so you get like 0.5 y double prime. plus 5y prime plus 13y is equal to 0 here on this. Okay, and then it's got to solve this one here with maybe some conditions on it here. Now this here, that's like a half, right? It's like a half there. So I guess if you multiply through by 2, you can clean up a little bit. It'd be y double prime plus 10y prime plus 26y equals. I don't like these numbers I'm getting. I don't think. Well, anyway, whatever. Yeah, okay. Say something like this here. Yeah, it could be a messy thing like this, I suppose. I think I might have had a different number there, maybe. But anyway, so I give you the M, I give you the C, I give you the K. So you just got to solve this, and you have initial conditions here. This one I went through by, that was a half here, right? So I went through by 2, double the numbers there. Okay, and then I thought this would go factor nice, but apparently not. Any questions there so far on it? It's okay. So then you'd use the formula here. Like, you got r squared plus 10r plus 26 equals 0. Okay. Yeah, I guess this comes up to be a mess, this one. So then you get r equals negative 10 plus or minus square root of 100 or 10 squared minus 4 times a times c all divided by 2a. And I don't know if anything nice happens here on this. A negative 10 plus or minus. Does this have to be a nice number? 100, if you do 100 minus, I don't know what I was going for here, but 100 minus, that's 104. Oh, okay. It's 104, right? Okay, so that's going to be negative 4, right? So negative 4, and then, so I guess, okay. It's not bad. So it's square root of negative 4 here. This is negative 4. Square root of negative 4 is 2i, right? So plus or minus 2i over 2. Not bad. Okay. So then you get r equals negative 5 plus or minus I, like this here. Okay. So then that would be what y equals, now it goes c1 e to the negative 5t cosine t plus c2 e to the negative 5t sine t. That'd be your general solution like this. Like this here, because the real part, that's the e, and then imaginary part, that it's like 1 and 1 there. You first see this, and then you find your constants, right? So you got your constants then, kind of like before, right? If you bring these down here, so y of z equals 1, y prime of 0 equals 1. A bit of a mess though on this, because you got to take the derivative. Okay, product rule. So y prime have to use product. I'm not going to go through this, but product rule there. It may not be on the test quite like this, something like this, but you have to use the product rule there for that. Okay, and then you can fill in your conditions here, and things would cancel out when you fill in those conditions. You get the C1 and C2 then. So okay, so any questions on that one? Let's see. Okay, so I guess we'll leave it there then for that. So okay, so I'll stop recording here then.